Welcome to all. We'll continue. See, previous class I was giving standard expressions for support reactions. I told all the summary, everything was explained earlier, only standard cases. This is you have to remember. But always try to remember by principle. So start one by one. Now, standard case of support reaction, simply support beam continued. UVL, uniformly varying load, represented by a triangle. Okay. Just standard case, two cases. See, uniformly varying load of intensity 0 at one end and maximum at the other end. In this sketch, left side 0, right side maximum. Maximum intensity is W per unit length. Or, again same thing here. 0 at one end, maximum other end, here left side maximum. Everything explained for you. Line of action of resultant will be here. Here it will come somewhere here. Everything explained for you. I will put answer here. This answer is WL by 6. This is WL by 3. Here this will be WL by 3, WL by 6. I won't explain how it came. Everything was very thoroughly explained earlier. You should go through earlier classes and make note. This is actually summary I am giving. Okay. Or, see here, it's actually or. Both are same case. See, it is one of the case. And also, one more case. Uniformly varying load, 0 intensity at the ends. Both ends 0. And linearly increases to maximum of W per unit length at center. Now reaction is, see, even I am writing the answer by how, not by hurting. I am seeing the loading there and getting the answer. WL by 4, WL by 4, WL by 4. Why 4 means in the total load half will be there, divided by 2 is there. Okay. This is one round. Now one small second round. Make a note here. Also, you make a note here. Once again you have to write, instead of intensity given, if the total load given, see, that is intensity, you have to write once again, statement you write, all these three cases. Suppose intensity is given, simply in the question it is given total load. Sometimes it happens in examination, W, capital W, here also. Total load is W. Here also given, this complete total load is W. In that case, if you want intensity, what you should do? Half into L into this intensity equal to W. This intensity will come 2 times of capital W divided by L in all the three cases. That's all I explain. Or you try. Now, you only answer. Now, answer. Here, answer is W. So, no L in W by 3, 2W by 3. Here, 2W by 3 here, W by 3 here, W by 3. Whereas here, W by 2, W by 2 over. This is the answer. Okay. Now, I will write next, after UVL represented by a triangle, I will write next case, continued, see, couples. For that I have to write something, so I will clean the board and write and then start. Otherwise, the time is wasted. Start now. Standard case of both reaction simply support beam continued. When simply support beam is subjected to only couple or couples. Couples means any number of couples. But remember, only couple, no other loading. No other loading. Very important. If other loadings are there, then you have to go for first principles. That is, sigma m0, sigma b0. It is a standard case is only for couple. Now, let M be the net couple. If single couple is there, that couple itself will be M. Why? Only one couple. And if multiple number of couples are there, then that M I told net couple will be net or resultant couple. If multiple couples are there, you consider single couple. Also note, as far as support reactions are considered, see, very important, as far as support reactions are considered for simply supported beam, that is for determinate structure. It is not valid for indeterminate structure later. I will tell you later. Considered couple or couples can be anywhere. Means can be anywhere. Where I wrote something. Okay, can be anywhere. That means you can write here. It does not matter where is the couple or couples. It can be at the support. It can be at the center. It can be eccentric. Whatever it is. See, I will tell you one sketch here. Simply supported beam. Only couple means it can be here. It can be here. I am not showing arrow mark because why? I don't want to show clockwise, anti-clockwise. Something is there, direction. It can be anywhere here, or it can be here, it can be here, it can be here, or it can be here, it can be here. Okay, I mark clockwise here, okay, this way. It does not matter where is the couple. But remember, only couple. So, as far as support reactions are considered, it does not matter. Multiple couple means consider single couple resultant. Note, but for SSB BMD later, also for deflection, also you can write here, also for bending stress chapter, and also you can write for analysis of statically indeterminate structure. Then it matters where is the couple. Then you cannot tell let the couple be wherever is the couple does not matter is wrong. It matters where is the couple. Okay, now right now we are doing simply support beam. So for simply as far as support reactions considered, see, considered for simply supported beam right now, and also little later for cantilevers. I will tell now only. I won't explain once again. Also for cantilever, because both are statically determinate. Only for support reaction, it does not matter. Remember that one. Okay, now I will give standard cases. See, there are two standard cases. One when net couple, either single couple or net couple is clockwise, and then net or single couple is anti-clockwise. See, for example, if that M, I told M is what? Either single couple or net couple if multiple number of couples are acting. If that M is clockwise or, you write here, is clockwise or anti-clockwise. M. This way. See now, first, if clockwise, I can show the couple. See, I will close my eyes. Simply randomly, I will apply couple. Net couple M. AB. Spaniel. Or randomly M. AB. Couple anti-clockwise. Spaniel. See, I am not bothered where is the couple distance. The reaction will be here. This side down, VA will be down now of M by L, VB, I should write reaction, some other sketch. Okay, sorry. See, reaction, some other sketch, not same sketch. First you write only, show the beam, okay, below, reaction. See. Answer. A, B, A, B. Here, so up to here, the reaction VA will be down M by L. Here, reaction VB will be up M by L. I explained so thoroughly earlier, maybe half an hour I took for this one. Here, if it is this way, then reaction VA will be upwards of M by L. This reaction VB will be downwards of M by L. M is the net couple. I'll give a small example for you. See, one small example. If, you write here, if single couple M given, okay, yes, M is M. Or, in case M, 2M, not M, randomly, see. Suppose say, okay, I'll put numerical to make more clear. 60 kilonewton meter, 50 kilonewton meter, and one more here, 40 kilonewton meter. Then that single couple M will be 60 clockwise, 50 clockwise, 110 clockwise. Oh, sorry, this I will make anti-clockwise. Okay, anti-clockwise. 60 clockwise, 50 clockwise, 110 clockwise, 40 anti-clockwise. It will become clockwise of 70 kilonewton meter. This is your M. Or, right here, one more sketch, or here, right, or. Suppose the couples are anywhere, one anti-clockwise of 100 kilonewton meter and one clockwise of 60 kilonewton meter and another clockwise, okay, 10 kilonewton meter. Oh, once again, same answer. No, I don't want same answer. Of 20 kilonewton meter. Randomly, then that net couple M will be anti-clockwise 100, clockwise 60, clockwise 20 is net of these two is clockwise 80, anti-clockwise 100. So anti-clockwise of that M will be anti-clockwise of 20 kilonewton meter. Here, correct? Huh? Clockwise, correct. Just an example. So, but remember, in the expression here, M is the net couple. Okay, now this will complete your simply support beam with the loading and couple. Now I will go for simply support beam with overhang. I will cover now only. Because why? Very small. Very, very small. With overhangs. Then I will go for cantilever. There, lot of cases are there. Today also it will be over now. Everything will be covered today. Okay, now, standard case of simply support beam with overhangs. With overhangs. Remember, usually standard case is, other cases all you should study by basic principle. If, say, one side overhang is there or some other loading is there, I will do only for UDL now. That all you have to calculate. We will do it. So, standard case is simply supported beam with two equal overhangs. Equal overhangs on either side. Very important, equal overhangs on either side. And subjected to only UDL over the, not between, over the entire length. Entire length. That means, you write here, the UDL should cover not only the beam between the support from extreme left free end up to extreme right free end. That is, see, both overhangs are equal and full UDL. This is standard case. Now, first to make this note, I'm rubbing this one. See, rubbing because why? Already over. You should write all these. When you make a fair copy, write all these. Now, see, this way. This is the beam. I will take one support here, one support here. This I will take left side overhang, yes. This I will take right side overhang, yes, both are equal. And between the two support, distance, I will take L. I will call this as A and B. Ends I don't want to call. This is UDL for entire span. This is a very easy case. Intensity is W per unit length. W per unit length. Here, overhangs are given, yes. L is the distance between the supports. In that case, the support reactions are, I will put here now, one by one. Here, see, this is A, this is B, full UDL. This reaction VA, this reaction VB, both will be equal to W into L plus 2S. You can write here. L plus 2S. Intensity into total loaded length. Answer divided by 2. Or you can write WL by 2 plus WS. Here also it will be W into L plus 2S whole divided by 2. See, these two you can also write as WL by 2, that is for this UDL, plus WS. Both are same. See, both are same. You can make a note here, or you can write this answer here. See, or it is WL by 2 plus WS. This also WL by 2 plus WS. Now, same, make a note. Suppose, right here, make a note here. Make a note. Suppose overhangs are equal. See, overhangs are equal. Hangs are equal. And entire length given. Entire length given. Say capital L, that is this one. L. How much is the distance between support and overhang? No idea, not required. But one thing important, overhangs are equal. Be careful, overhangs are equal and full length is L. Then what will happen is the reaction will become simply reaction VA will be W into L by 2. This VB also will be equal to W into L by 2. Over. Why? W into L is the total load divided by 2. Okay, now, one more note you make. One more note. Suppose this is given as S. This also given as S. Span is given as L. And instead of giving intensity, it is given the total load is W. Total is W. In that case, directly answer. Directly see, now in the reaction, L and S will not come. It is VA equal to W by 2. VB also equal to W by 2. Make a note. Same thing, or one more sketch. Overhangs are equal. No idea about span all. Total length is L. Then also answer is, because why? Total W. So L will not come. W by 2, W by 2. Make all these notes. Actually, common sense is sufficient to understand this one. Okay, now, standard cases for simply support beam are over. If anything else is there, you do by basic calculation. These all you have to remember. And now, lastly, closing part. Lastly, standard cases. standard cases of support reactions for cantilevers. I will write each and everything now, see. Okay, now some writing is there. I will write it. Start. Okay, now for cantilever, L means span or length. Capital W, sometimes people use P also, but I use capital W. Sometimes instead of W, you can put P. That's okay, your choice. Magnitude of concentrated load or point load. And also, in my class, in case of UDL or UVL, if they give total load, it is capital W, total. Whereas small w is intensity of either UDL or UVL, that is W per unit length. Okay, sufficient. See, start. You write heading. I am not writing. See, heading here. Concentrated load at the free end. W at the free end. See, reaction. WL. Here, this is anti-clockwise here, but here, VB is WL, over. Okay, next write here. You should write concentrated load anywhere, say at S from fixed support. Very important, fixed support, very, very important. Not from left side, right side. See, a load W at S from fixed support. Suppose the span given is 10 meter, is 4 meter. If they give 1.5 meter, you should take S 2.5. See here also. Load W, S from fixed support, not from free end. Same thing here. See, suppose span is L. A load is given, the span is 3 meter. They will tell this is 1 meter. You should not take 1 meter. From fixed support, it become 2 meter. Okay, answer. VAW, VBW. This will become WS. Why means already explained. See, this is not the time to explain how the result came. How much time I spent earlier. Okay, this is for concentrated load. Okay, now, next. UDL. Not much cases. Few cases, UDL. See, first write UDL for entire length. See, W per unit length. I am writing only standard cases, or it can be like this also. Right side fixed. So it does not matter which. I am not telling left side, right side. One side fixed, one side free. Unit length. Span is L. Left side I will call A, right side B. Left I will call A, right side B. Span is L. Now, reactions. Answer. I did not write AB every time, but what to do? Have it. AB. Other things you write. VA, WL, MA, WL square by 2. VB, WL, MB, WL square by 2. You write this much. Now make a note. Make a note here. In case, instead of intensity, total load given. See, sometimes confusion. Total load is given as capital W. Here, it is given total load is capital W. Then the answer is These all reasons are there. Everything is placed here. W. Here. VB equal to W. W, L, no L square. W, L by 2. W, L by 2. Why? W is the total load into L by 2. Okay, that's all explained earlier. Okay, next. This case over. I'll go for more cases now. Not much case. Limited number of cases for cantilever. I won't waste time for unnecessary cases. If anything else given, you solve later when you draw SFDBMD or any problem you are doing. If some other type of loads are given, it is not called standard case. That you solve at that time, I will solve it. This is immediate answer. See, or UDL starting from fixed end and extending for a length S from fixed end. Remember, from fixed end, not from free end. That is, see here. Intensity given, W per unit length. A and B, span is L, load is for a length of S from fixed end. Here, or it can be like this also. W per unit length, loaded for a length of S from fixed end, span is L. Answer, AB. Okay, AB. S can be anything. It can come up to center any distance. Answer is here. See, I will give real standard cases. This is the loading. A, B. See, none of them I come here by hearting. See how I am writing. You should have confidence. Oh, this person can write directly. One fine day you should decide that you should tell, okay, one fine day I also will reach the same level. I'll be very, very happy. VA equal to W into S. VB equal to W into S. This reacting moment MA, W S square by 2, W S into S by 2. Reacting moment M. Remember, MB. This is only if the UDL is starting from fixed, when it's starting from fixed end for length L. Okay, now, same thing, make a note. Instead of intensity, write one more scale. Again you have to write. If they tell total W, if they give in the question, total load is W, then W S by 2, W S by 2 over. Now, if the UDL starts from free end or if it is somewhere in between, that all we will solve. It is not called that much standard case. It is that then you can do one thing. It is never ending. That's all you can't remember. Real standard case is either UDL for full span or starting from fixed end up to some length. Okay. Now come to UVL. Over. We are almost closing now. Only 2 more cases left. 2 more cases. UVL. See. Or spaniel. Actually, this way double is not required, but my teaching is always that I do not want anybody to get confusion. See, UVL with intensity 0 at the free end and maximum of W per unit length at the fixed end, not left right side. See, I told 0 at free end and maximum of W per unit length at the fixed end. See here, 0 at free end and maximum of W per unit length. You should not by heart left right unit length at the fixed end. Okay, answer. Okay, I won't write ABCD now. How many times I have to write ABCD? I wrote AB here, sufficient. If I write AB, again AB only. Why you want to waste time? Okay, see here. VA equal to WL by 2. Here. VB equal to WL by 2. And this reacting moment, MA, this reacting moment, MB. This will be WL by 2 into 1 by 3. Okay. See, I got it. WL square by 6. This also WL square by 6. How I came? Half into L into W total load. That is WL by 2 is a total load into 1/3 of L. L by L, 1/3 of L is WL square by 6. Okay, leave it. Now, make a note for the same case. Instead of intensity given, if by chance in the question, if total load given, total load is given as say W, here also, if they give total load is W, in that case, the answer is W into WL by 3, WL by 3, correct? W into 1/3 L, okay. This is one case, okay. Now, another case, see here, right, once again, UVL, you should not do this way. If you write separately, once again, don't. UVL with 0 intensity at the fixed end and maximum at the free end. See, this way. This is W per unit length. Here, 0 at the fixed end and maximum of W per unit length at the free end, reverse. In that case, this reaction VA equal to WL by 2, same answer as last time. Here also VB equal to WL by 2, but the moment will change, WL by 2 into 2/3 L. It is, see, I got the answer. WL square by 3, this is WL square by 3, not 6. Last, because WL by 2 is the total load into 2/3 of L, 2 will cancel. Okay, leave it. Now, make a note. Same case, instead of intensity, in the question, you have to write everything once again. If total load is given, total load is given as a W, or here, total is given as W, then the reaction will be W, because in cantilever, vertical reaction is always equal to total load. Simply support beam, 2 supports are there. And this will be, moment will be W into 2/3 L, 2WL by 3. WL by L, W into 2 by 3L. Okay, 2WL by 3. This also 2WL, no L square now, by 3. Last time, see, when intensity given, W into L, W into L square. Now W and WL. Okay. Now this is also our last case of UVL. See, I am giving non-stop standard result. Everything was covered earlier. Otherwise, I won't give this way. Lastly, right here, cantilever beam with uniformly varying load, both ends 0 and maximum at center of W per unit length. Intensity given. Unit length. Span L. Span is L and correctly maximum at center. See, little out of scale. Okay, center. L by 2, L by 2. Or it can be like this also. Intensity W per unit length, span is L and maximum exactly center L by 2, L by 2. Now this is A, this is B, A, B. Answer. Your VA will be W into L by 2. VB also here W into L by 2. See, earlier it was WL by, there also WL by 2. But moment will change. And the reacting moment MA here will be WL by L by 2, WL square by 4. How? WL by 2 is the total load into L by 2. WL square by 4. This reaction MB equal to small w, small w, L square by 4. Okay, now make a note. By chance, for this case, once again you are right, if they give total W, see I am taking care of each and every case. If they give not intensity, total load W, then this reaction will be W, this reaction also will be W, this moment will be reacting moment W, L by 2, everything proved earlier, W, capital W, L by 2, no L square. This is lastly for uniformly varying load. Now, to close the standard cases, last part over. So today is a very short class. Actually, yesterday only, previous class only I would have completed, but I was feeling little tired. That's why I can. So today's title will be simply supported continued and also overhanging beams and cantilevers. Okay, now, lastly, cantilever beam subjected to either subject to only couple or multiple couples. Anything will do. Multiple couples. If only couple, it is M. If multiple couple is there, then M stands for net couple. This is already explained earlier. But important, make a note. No other loading other than couples. And for support reaction, it does not matter. Right here, it does not matter where is the couple. Couple can be anywhere. It can be at the free end, in between, or it is somewhere there, somewhere here, anywhere. But remember, that is only for support reaction. All I told earlier. But remember, again right, for SFD BMD or for deflection or bending stress chapter or cantilever is statically determinate case, so therefore no question of what? Indeterminate. Then it matters. In that case, SFD BMD all, you should know where is the couple. But there also, when you find reactions, you need not bother. So, two cases here. Imagine a cantilever beam fixed at left end, A, B, span L. Let there be a net clockwise couple M, left side fixed. Where? Anywhere. See, I am not writing where. It can be anywhere. See, that couple is right here. Couple can be anywhere. Couple can be anywhere, does not matter where, then answer. This reaction VA equal to 0. If it is a clockwise couple, reacting moment is anti-clockwise, MA equal to M. Make one more note. Same cantilever, if the couple is anti-clockwise M. Make a note. Then also VA equal to 0, but MA will be clockwise of M. One more case. Write this case. Then here, second time you are right. No, don't single sketch. Or if the beam is fixed at right end, here, if there is a clockwise couple M is there, where anywhere span L, the reaction will be AB. AB. This reaction VB equal to 0. If it is a clockwise here, reacting moment MB will be anti-clockwise equal to M. Then write once again. By chance, if the couple is anti-clockwise M, net couple, then it is a clockwise reaction of M. Couple can be anywhere. It can be single couple or any number of couples. Okay, this will complete the standard cases for support reaction. Now I will tell you what I will do now. From next class onward, marathon, 2-3 classes. Each class will be at least 1 hour duration. I will give how to find support reaction for all the cases we covered earlier, but not too much complication. What is required for academic purpose or competitive examination or practical field, not putting everything, one UDL, one point load, one couple, varying load. No, that much I am not giving. That is important examples. I will write question, answer, one round. Each round I may cover up to 3 or 4 questions. Number of questions will continue, maybe more than 100. So what you have to do is thoroughly practice standard cases, and from tomorrow onwards, next class onwards, whatever question I give, you take a book and correctly solve, get the answer, and when I finish this one, and then when I go to part 3, by that time you should tell, now I am expert in finding support reaction. How much he is knowing, I am knowing. Almost same I am also knowing, you should tell. If not equal, say maybe slightly lesser. If you tell, no, suppose you tell, no, now I know much better than him, there will be no happy person than me, because I only taught you. Okay. If at all it happens, okay, thank you. Next class we will meet with exercises for you, but very, very important. I'll put title there and start. Thank you.